I love LA. I'm happy to be back. Yeah, I think that you know, Kobe and I kind of started in Ruby at about the same time, and one of the things I'm proudest of is Confreaks, actually. So I've heard from developers literally all over the world who have been helped by having conference presentations online. And so I have a big love for conferences. I love coming here. I love meeting with everybody. And I love that magic happens at conferences, and we get to share that online. So, like I said, one of the things I'm proudest of is that Confreaks is a thing, and I had a little part in starting that. So that said, I made a promise that I would talk about how to design Rails apps to avoid a rewrite in 5 years. Because I think that that might be something that you might be interested in. So hello, I'm super excited to be here. And first post, I love going first because then I can enjoy the rest of the conference. Kobe already had everybody raise their hands. Can we do it again real quick? Like, how many people here are at LA Ruby for the first time? I mean, that's like the vast majority. I think at least 3/4. And then who's the very first Ruby conference? I think it was like half. Yeah, about half. So who's like been using Ruby or Rails for less than 2 years? Yeah, about 1/3 to 1/2. Okay. And of those folks, who has been programming for less than 2 years? Okay. So not too many. So about 1/3 have been doing Ruby for less than 2 years, but this is the first conference for the vast majority. So awesome. On behalf of, I took a poll, and I can officially say on behalf of the organizers and speakers and everybody who's been here before, welcome. We're happy to have you. Okay. I want to talk about a problem, and the problem I have seen in the Ruby world, in the Rails land, for about 8 years now. And it's that legacy apps exist, and which is like a bizarre, crazy thing for me to think about, because it was just last year we were all on Slashdot reading about the 10 times productivity increase of Rails and how that was total BS and having those fights, right? But all of a sudden, it's like, oh no, that wasn't last year, it was 10 years ago, and people have been writing Rails apps for 10 years and putting them in production. And that's been fantastic because Rails is such a wonderfully productive web framework that you can do that and it works. And those apps are great. But that also means that there are literally many, many thousands of applications that are out there in the wild. And they need to be maintained. And so I guess another show of hands, who considers themselves to be working on a legacy Rails app? Yeah, about 1/3 of the room. Who would prefer to work on a greenfield app than a legacy Rails app? I think pretty much everybody. So why is that? I have thoughts. So that, in my mind, is kind of the problem. The problem is that we have legacy Rails apps, or that concept of a legacy Rails app exists. Let's talk about a little bit about the pain. What specifically is a pain with dealing with legacy Rails apps? Like, if you have a legacy Rails app, and that's like a very nebulous definition, right? What does it mean to be legacy? But if you have what you consider to be a legacy Rails app, what pain do you feel from it? Why would you consider it legacy and not like an active app?
Hard to change.
Hard to change? What else?
Technical debt.
Technical debt? Okay.
Yeah, just it can be hard to figure out what's going on.
Hard to figure out what's going on. That's the thing that kills me. Yeah, Michael.
I have apps that are working fine, and I don't have any worldly reason to change them, yet some gem will break. It causes this like a chain reaction of things that have to be upgraded, and suddenly I have to, like, the old routing doesn't work anymore, and now the whole blows up.
Yeah.
When like I just want, it's working perfectly, leave it alone.
Yep, the gem ecosystem kind of changes underneath you, or there's a hot fix, on some vulnerability that gets patched, and all of a sudden you can't use what you're using before, and you've got to do like multiple generations of Rails upgrades. Yep, I hate that as well. All right, so we've got this problem of legacy. We've got the pain that we feel. And I don't know about you, but like my first reaction is just to rewrite it. Like, I don't want to deal with it. And that kind of says something, I think, about like how easy it is to write apps within the Rails world. But I think it also says something about how we view the permanence of the apps that we do build. Like for example, let's say you've got an app that's working fine, it's all built on jQuery using sprinkled JavaScript, and you want to rewrite it into React. I kind of think you don't need to rebuild your app to do that. But a lot of people actually do have to, because those concerns about the presentation layer are buried so deep into their app that it's hard for it to change. Okay, so the question then in my mind is, if we have a problem with legacy apps being unmaintainable, how do we build maintainable apps? How do we avoid legacy decisions? And I think the real question is rewriting to microservices the only viable answer at this point? Right? And I think that that's not the only viable answer, but it still exists. This thing exists where we have pain from legacy apps because they're difficult to change, they're difficult to understand, and how can we avoid that? How can we solve that pain without rewriting it to Node and microservices? Can we still have fun in legacy apps? Can we still have that greenfield excitement in legacy apps? And I think you can. So what is the answer? Well, simply the answer is you're doing it wrong. Well, it's not entirely true. I think that you're thinking about it wrong. I'm going to explain what I mean by that. I've seen this pattern over and over for the past 10 years in the Ruby and Rails world, and about 10 years before that as well. So I have this concept that I'm going to share with you on what I think leads to building maintainable apps, and it's not entirely what I think you think it is. So in order to start down this path of uncovering what this idea is, let's back up and talk about a little bit of the basic. What is software? If someone came up to you and said, oh, you do software, what is that? What do you say to them? What is programming? What do you do? It's dark magic? Sometimes, yeah. Science experiments? Translations? Yeah, I like that. Anybody else? Creation? That's good. I like that. Anybody else?
Transformation.
Data transformation? In a lot of ways, yep. Bending the computer to your will, yes. What I hear most often is you generate instructions for a computer to follow, right? You probably agree with that. Well, I kind of think that that's a little bit wrong. It's not entirely wrong, but the emphasis is misplaced. Has anybody seen this book before, The Structure and Interpretation of Computer Programs? Yeah, about a quarter of the room, good. You can read this online. It's at MIT Press. This is a very consequential book that was I think it was authored in the 1980s from MIT for their intro to computer science program, right? So they wanted to take people who were coming into computer science and give them this foundation that everyone was going to share. And it's very different than how I learned how to program, and very different than how most people I talk with have learned how to program. So different that you don't have to go further than the preface to really find a big difference. So I'm going to share a quote with you. This comes from the preface. So it says, our design of this introductory computer science subject reflects two major concerns. First, we want to establish the idea that a computer language is not just a way of getting a computer to perform operations, but rather it is a novel formal medium for expressing ideas about methodology. Thus, programs must be written for people to read and only incidentally for machines to execute. Second, We believe that the essential material to be addressed by a subject at this level, again, this is an introductory course, is not the syntax of a particular programming language constructs, nor clever algorithms for computing particular functions efficiently, nor even the mathematical analysis of algorithms and the foundations of computing, but rather the techniques used to control the intellectual complexity of large software systems. Now, when I first read this, that just jumped out at me. I had never thought of software as a mechanism for controlling intellectual complexity, and that fundamentally changed what I think of as my job. This notion that software is a vehicle for intellectual complexity. It is intellectual complexity. When we craft software, we are crafting ideas. We're moving this complexity around to communicate to other people. So we then at this part, our job is not to write down instructions for a computer to follow. It is to craft an idea. It is to express that idea. So we are workers of knowledge, right? We're workers of ideas. We get to create things out of nothing other than ideas. And I think that's wonderful and fascinating. This is an incredibly difficult thing to do, but it is a noble thing to do, right? Not many people can get paid to work in nothing but ideas. So I hope that you can share a little bit of my awe of this idea, but I am truly in awe of the idea of that. It goes on a little bit later and says this. Underlying our approach to this subject is our conviction that computer science is not a science and that its significance has little to do with computers. The computer revolution is a revolution in the way we think and in the way we express what we think, right? So if we're doing it wrong, I think it's because we are thinking about software wrong. We rewrite apps not because they're old. It's because the apps are not communicating their intellectual complexity well enough. The computer doesn't care. The computer will continue to run the app, except for the case of the dependency changes. But it's going to run it just fine. You can have the most complex, convoluted app. The computer will still run it. The problem that necessitates a rewrite is not the computer running it. It's people understanding it. So this is the key. Other programmers are more important than the computer in how we write code. So we just need to learn how to express what we think about software better than we're doing it now. Because in a lot of ways, we're not doing a very good job. Has anybody here heard the term big ball of mud? About a third of the room. Cool. Big ball of mud, this is a pretty influential paper that came out, I think, 20 years or so ago. And it's online. I've got the URL a little bit later. It's described, a big ball of mud is described as a casually, even haphazardly structured system. Its organization, if one can call it that, is dictated more by expediency than design. Does that seem familiar at all to anybody's legacy Rails apps? Right? It certainly does to mine. Here's the URL. Please go and read this paper because it's fantastic. To me, if you have a big ball of mud application, what that big ball of mud application is telling you is that you're not smart. You're not smart enough to understand it. And I think that's incredibly disheartening because you are smart enough to understand it. The problem is that the people who were in charge of that app did a very poor job of expressing that intellectual complexity in a way that you can understand, right? And it's kind of punishing. In fact, I think it's unfair in a lot of ways. And I want you, whenever you run into that situation, to really embrace and remember how that feels, that frustration and that disappointment, that negativity, that you don't understand why this choice would be made. Because the apps that you write, you make other people feel that way all the time, right? And that's because, again, that's the fundamental problem. We don't express intent well enough. Okay, so I'm almost done setting up the problem. People have heard of technical debt, right? Who has heard of technical debt? Okay, about half the room. Technical debt is a metaphor that was coined by Ward Cunningham, and I found out late last night, that I've got more time than I thought. So I'm actually going to play a video to pad out my time. But this is Ward Kimball explaining the metaphor of technical debt. I think that it's an incredibly important thing to understand. And again, we tend to discuss technical debt in a way that is not entirely what Ward Cunningham expects us to talk about technical debt, or the way it was originally intended. So let's see if this will work.
I became interested in the way metaphors influence how we think after reading George Lakoff and Mark Johnson's Metaphors We Live By. An important idea is that we reason by analogy with the metaphors that have entered our language. I coined the debt metaphor to explain the refactoring that we were doing on the Y-Cash product. This was an early product done in Digitalk Smalltalk, and it was important to me that we accumulate the learnings we did about the application over time by modifying the program to look as if it had been, as if we had known what we were doing all along, and to look as if it had been easy to do in Smalltalk. The explanation I gave to my boss, and this was financial software, was a financial analogy I called the debt metaphor. And that said that if we failed to make our program align with what we then understood to be the proper way to think about our financial objects, then we were going to continually stumble over that disagreement, and that would slow us down, which is like paying interest on a loan. With borrowed money, you can do something sooner than you might otherwise, but then until you pay back that money, you'll be paying interest. I thought borrowing money was a good idea. I thought that rushing software out the door to get some experience with it was a good idea, but that of course you would eventually go back, and as you learn things about that software, you would repay that loan by refactoring the program to reflect your experience as you acquired it. I think that there were plenty of cases where people would rush software out the door and learn things, but never put that learning back into the program, and that by analogy was borrowing money, thinking that you never had to pay it back. Of course, if you do that, say with your credit card, eventually all your income goes to interest and your purchasing power goes to zero. By the same token, if you develop a program for a long period of time by only adding features and never reorganizing it to reflect your understanding of those features, then eventually that program simply does not contain any understanding, and all efforts to work on it take longer and longer. In other words, the interest is total. You'll make zero progress. A lot of bloggers, at least, have explained the debt metaphor and confused it, I think, with the idea that you could write code poorly with the intention of doing a good job later, and thinking that that was the primary source of debt. I'm never in a favor of writing code poorly, but I am in favor of writing code to reflect your current understanding of a problem, even if that understanding is partial. If you want to be able to go into debt that way by developing software that you don't completely understand, you're wise to make that software reflect your understanding as best you can, so that when it does come time to refactor, it's clear what you were thinking when you wrote it, and making it easier to refactor it into what your current thinking is now. In other words, the whole debt metaphor, or let's say the ability to pay back debt and make the debt metaphor work for your advantage, depends upon you writing code that is clean enough to be able to refactor as you come to understand your problem. I think that's a good methodology. It's at the heart of extreme programming, the debt metaphor is an explanation, one of many explanations of why extreme programming works.
How's that?
Now,
I found that
the whole debt metaphor
on that video, and that's on YouTube, so you can go and grab that and share that with everybody all the time. When I first heard the metaphor of technical debt, it was synonymous with a big ball of mud. It was synonymous with you just have crappy code, right? And that's not what he's saying. What Ward's saying is that your app wants to be the most perfect understanding of the problem expressed in the very best way. And to the extent that it's not, because that's a difficult thing to achieve, you're borrowing against that. And that metaphor works if you're a financial person. It does not work for discussing having an app that is difficult to manage, right? Technical debt is one of those things that you take out intentionally, right? Rarely do people kind of fall into debt. There's usually, they're usually aware of it at first. Okay, so we've got big ball of mud, which is a haphazard kind of like growing a design by not focusing on the design, and we've got this idea of technical debt. So we need to be able to communicate our ideas, right? I love Ward's idea that the app wants to be the most perfect understanding of the problem expressed in the absolute very best way, right? At that time. And if you've got an app that has existed for 5 years, by that 5th year, it should be pristine because it reflects 5 years of understanding, right? It should. And that's to the point that if it doesn't express 5 years of current understanding, then you've either got a ball of mud or you've intentionally taken on technical debt. So the way we get around this is we have to focus on intent. We have to ask ourselves, what is the intent of the system rather than what instructions do we need to write in order to achieve it, right? So we need to take a step back and think about design a little bit. And this is one of the things that we have a tremendous advantage. We're actually way far ahead of a lot of other communities because we've got this thing that helps us more than you know, and that thing is Ruby. Ruby is a fantastic language for domain modeling, which is what we're talking about. The idea of coming up with a design, modeling that design in software. Ruby excels at it, right? I could go on about how fantastic Ruby is, but we have an entire day talking about how fantastic Ruby is. So I'm going to let them do it. One of the keys for me for doing this within Ruby is this term called anthropomorphization. Who has heard of this term before? About half the room. What does this mean? To make human? To treat something like a person. Yeah, to ascribe human qualities to an otherwise non-human entity, right? So, if you say, oh, my dog, well, I guess the dog could actually truly be happy to see you, but yeah, basically this, right? If you put a human face on something that's not human, this is anthropomorphization, right? This is key in my mind to designing really great software. We have to give our software human characteristics and human qualities. For example, has anybody ever heard, oh, I want this code to be lazy? Who's heard something like that, right? Well, I mean, lazy is a very human quality. That's a little bit of anthropomorphization. The thing about this, to really truly do this and to do this consistently throughout your entire app, it's counterintuitive. It's not an easy thing to do. It's a lot easier to say than it is to do. And I also think that it goes against everything we are taught about how to program, right? Like when I first learned how to code, it was in C and C++, and it was very much about the instruction set. It was not at all about the design, right? So it took me a very, very long time to kind of come around to think about software in this way. Like Ward said, metaphor is a really important key part. It's one of the 12 practices of extreme programming. And I find metaphor also a very important part of coming up with a good design. There's a particular metaphor that I want to use for the remainder of talking about code, and it comes from Rebecca Wolfsbrock, her book, Object Design. And it's this metaphor of a code neighborhood, right? And what she says is that if you look at your code, so imagine like you're opening up your Rails app, you're looking in your models directory, and you're taking a look at all of the code in there, they will naturally kind of group up into little neighborhoods, into little groups of objects that relate to each other, right? And more than that, the objects within that neighborhood, they will have a very high bandwidth communication between them. But as you go from neighborhood to neighborhood, you should have a more coarse-grained communication, right? It becomes a little more formal and something that is a little bit easier to document. So this idea of drawing boundaries around pieces of your app is incredibly important, right? And the fact of the matter is that you have several dozens of boundaries within your application. You probably just haven't recognized it yet. But recognizing it is actually key to writing maintainable software. So let's take an example. Let's take the prototypical blog example of a Rails app. You've got your user, right, which is your account, person that's logged in. You've probably got a post and a comment that exists within your application. And maybe you've got a tag and a category for kind of meta organization. I think that you can kind of group these individual entities into 3 different neighborhoods, right? A post and a comment, they need to know about user, since the user is the author of a post and a comment. Tags and categories, they probably don't know much about user at all, right? They probably don't care very much. They probably know a lot more about posts and comments. Posts and comments may know about tags, but they don't have to know about tags. Yeah, so if we could draw dependencies, right, the dependencies might go this way, right? And user could be blissfully unaware of anybody else within your domain, right? Now, typically, user knows about everything. It's the God object in your domain. But you can write it in this fashion, right? So here we've got 3 neighborhoods. If you have this, if this is all you've written, you have a running application. It doesn't have to be a web application. It probably doesn't make sense for a blog to not be a web application. But as a mental exercise, let's consider we wanted to build a Slack app or a Slack integration, right? And you wanted to be able to read and update a blog through Slack commands or IRC commands. You absolutely 100% could do it with what you have here, right? This is a functional application with no real formal interface, right? But this is your domain model. This is all you need to have a blog, is you need these entities. So this is your domain. And this domain modeling is a really, truly important part. So let's take a step up, and let's talk about what your Rails application is actually doing. So we had neighborhoods within the domain. Now let's consider the domain to have its own boundary, and it's its own neighborhood. And it's going to talk to other neighborhoods. So one of those other neighborhoods that are happening within your app, you've probably got a web user interface, right? This is your public user interface. When browsers come and hit your app, this is what they're seeing. You're going to read and update blog posts, add comments through this web UI. Now you probably also have some sort of administrative UI, right? Where you have a different domain to have its own, still working on blog posts and comments and tags, but you're doing other things with it. You've got 2 different sets of behavior, of responsibilities going on here. And to illustrate that, I want to talk about permissions, right? Let's talk about permissions within your blog app. So say, for example, let's talk about updating a post. If I was going to update a post on the web UI, I would have to have permissions to do that, which means I would have to be the author, right? You don't want just anybody to go and update a blog post and change the text of it. So your web UI, only the author can go and update the blog post. But in your administrative UI, you want to give the admins the ability to do that as well. Let's say someone accidentally posted some cross-site scripting JavaScript, and you want to go and take that out, right? You don't want to go directly to the database. You want to check that within the web UI and remove that, right? So it's a valid use case with 2 different sets of permissions. Well, where do those permissions belong? Where is the responsibility for those permissions? Are those responsibilities part of the core domain model? Or are they part of the other neighborhoods that are using the core domain model? Well, let's anthropomorphize Post and ask Post if he would like to check permissions for publishing. Right? All right, so Post, can authors publish? Well, Post, because he's a little surly guy, he's going to be like, or she, Post is going to say, I don't want to do that. Can't someone else verify authorship for publishing? Like, that's dumb. I don't want to do that. So if Post isn't going to do it, then who's going to do it? Well, how about web permission? Let's create some new entity, right, that will model this valid use case. Right? Your app needs to know whether or not a user can publish or can update a post. Right? So instead of asking Post, let's ask this other thing. And not only that, then we can also have a different entity for the administrative UI, right? And now everybody's happy. Post is happy because Post doesn't have to do any more work, right? Web permissions and admin permissions are happy because they get to exist, right? And so that's kind of what I mean about anthropomorphizing code. These are the decisions that we come up with. Come back to our previous model. We've got domain, the domain neighborhood, we've got our boundary, we've got our administrative boundary, and we've got our web boundary. Well, part of our web and administrative boundary also includes a sub-neighborhood for permissions, right? Because Post doesn't have it. Tests. Tests are really, truly important in this metaphor, this neighborhood boundary metaphor. Again, this is what we had before. We've got our domain boundary, our admin boundary, and our web boundary. Tests are actually the first client of domain, right? And so as you're going in, you're building the domain, the core domain neighborhood, or if you're making changes to it, you should first be making changes to your test and have your test drive changes within your domain. Has anybody worked on a Rails app that had so many tests, testing so many things that any change you made caused broken tests, or heaven forbid, like broken mocks and stubs everywhere? Yeah. Yeah, I had an entire app that had a 3.5-hour test suite, and I had to throw the vast majority of it away because it wasn't testing, it was all mocked out, and whenever you literally changed anything, tests would fail, even if you weren't changing behavior. The key here to thinking about your application in this manner is that this is what you test. You test around your domain. You don't test inside of your domain. You test that coarse-grained communication between neighborhoods. Everything else is implementation. Everything else is subject to change. As long as the behavior between neighborhoods doesn't change, you're good. With this approach, you actually end up testing a lot less, but the tests you have are way more valuable. Okay? So what do I mean by this? I kind of wanted to have some code examples, and I don't, but if you come up, we can go through your app and I'll show you what I mean. But a really good example, like a rule of thumb that I have, especially for Rails apps, is that if you are ever calling active record methods from outside of your domain, like within a controller or anywhere else, you have now violated that encapsulation. That's what I mean by that. So I consider active record to be an internal private API for your domain, right? You don't want to infect that implementation decision to other neighborhoods. Other neighborhoods don't need to know if you're using active record or you're using Mongo, right? It only needs to know what the behavior of that domain is. So what you should do if you have that instance is put a really good method around those active record calls, write a test for it in your domain tests, and then call that method from your controller. And what you've now done is you have defined your domain in your tests, which is exactly what the tests are supposed to do. Okay? Now, I have worked on many, many, many different Rails apps across many, many different teams. And I've come across a lot of different feelings, people's perceptions about testing, because everyone's had lots of different experiences with testing. With this approach, testing is fun. It's fun again. I promise you, testing is fun. And not only that, testing actually becomes super easy, right? The problem is that it takes a while to get a hang of it, right? And it takes a lot of discipline. And again, man, I'd love to show you this, but I don't want you to fixate too much on what the code changes are. I want you to really think about what this idea is. And the promise I want to leave you with is that your apps will not only become easier to maintain, but they will reflect your best understanding, and they will get better as the years go on, right? You should be spending the vast majority of your time within your app, within your tests, right? I think a lot of people don't do that, but you should. Let's see. The other thing about tests, we talked about our domain, and our domain has this boundary that we're testing, and our tests are our very first client or first consumer of the domain. Then we've got our web UI neighborhood, or this boundary within our application, and it's also a client. And so whatever your web UI is going to do on your domain should first be done within your domain tests. But your web UI is also going to have its own tests, because there's behavior that are specific to the web UI, and they need to be tested as well, right? So each boundary should have its own tests. Each neighborhood should have its own tests. So I want to leave you with a quote. I love quotes, and I love software. I love talking about this. This is one of my most favorite quotes about programming, and it is, often people, especially computer engineers, focus on the machines. They think, by doing this, the machine will run faster. By doing this, the machine will run more effectively. By doing this, the machine will something, something, something. They are focusing on the machines. But in fact, we need to focus on humans, on how humans care about doing programming or operating the application of the machines. We are the slaves, or we're the masters. I've done that before. We're the masters, they are the slaves. And that's Yukihiro Matsumoto, the creator of Ruby. So it's my hope, as we start another fantastic LA Ruby conference, to be mindful, to be a wise master. We're in control. If an app fails, the failure is ours, right? It's not a problem with Rails. It's not a problem with Rails design decisions. It's not a problem with Ruby or Ruby's performance. It's our fault, right? We've designed it to fail. So let's try to think a little bit differently about it. Let's improve how we think and improve what we do. So I hope you, thank you for the opportunity to talk. I hope you listened to all of the talks today, and if you have an idea, if some of my ideas are a little bit different than how you think, don't dismiss them right away. Try them on, give it a try, and see if it doesn't change you a little bit. At the end of today, I hope to be a much different person and hopefully a much better person. Thank you very much. My name is Mike Moore. I'm known as Blumage or Blumage online, and I have stickers. I work in the basement remotely, and I don't talk to people ever in real life. So it's been like months and months for me. So I have lots of stickers to give away. So please come and talk to me, because I need the social interaction. Thank you. There's a hand up over here. So the question is, can you give another example about testing around your domain? And I think the more important question is defining what is in your domain and what is out of your domain. So one of the mental exercises I like to run is I have 3 different clients that I judge a feature on. I judge a feature, and this is specifically to building a Rails app. Is this feature applicable on the public API? Is it applicable on the administrative API? And is it applicable on some sort of background job, right? And if it's specific to any one of those and doesn't really have a place on the others, then it doesn't belong in the domain. And then it becomes like a background job feature that is tested on the background job tests. And then other than that, I just think that your domain tests, you should organize them as an application, right? And you should build basically an app that tests all of the features that you need to expose in your domain to run your app. So that means I want to post a blog, I want to consume blogs, I want to search blogs, I want to find blogs by tag. So you should have tests for all of those use cases But what's great about that is that self-documenting. That's telling you exactly what your app does and how it's intended to be used, right? So when it comes down to building another web UI, you can look at your tests and almost copy and paste that code, drop it in your controllers, and know that they're going to work. Yeah. So the question is, speak about integration testing. How much of the interactions between all of the different neighborhoods do you test through an integration test? I don't have a slide for this, but J.B. Rainsberg, he has a really wonderful conference talk called, I think, Integration Tests Are a Lie, or a Scam, yeah. And what he says in that test is that, or in that talk is that if you, I wish I could draw it. Let's consider you've got like 3 different actors that are within the scope of your integration test. You've got actor A, B, and C. Actor A's got 4 different types of behaviors, potential behaviors that could have. B has 3, and C has 5, right? Well, if you're going to test every permutation of all of those behaviors, you're testing like 70 different things, right? And so if you're going to do true integration tests, that you're going to cover all of those permutations, you'd have 70 different integration tests. And it's just mathematically infeasible to test everything through integration tests. The closer you get to the actual object, the easier it is to test every permutation of all the different types of behaviors or potential outcomes. So my approach to integration tests is they're sanity checks. I want to make sure that it works. I want to make sure that if it doesn't work, it's going to tell me. But if the only failure I have is an integration test and not more of like a model test, then I've got bad tests on the model test. Like, I should have failures in both places. But it's entirely possible to only have model test failures because you can't test every single permutation. The other thing I use integration tests for, if I'm doing like a regression test, like something happened that was bad, I'm going to set up an integration test with that specific combination of bad settings and specify what I want the right behavior is, and then go fix everything to make sure that it works. Yeah. So Ryan's point is that with a GoToRuga speaker talking about Cucumber, that if you have more than 5 scenarios within a Cucumber test, it's too much. And I agree with that. There's another approach that predates BDD called ATDD, Acceptance Test-Driven Design. And it says the same thing. You have this big integration acceptance test as a goal that's going to fail and fail for a long time as you go back and bottom up do all of your other testing. And then once all this other stuff passes, at some point your acceptance test will pass, and then you're done, right? And I think that's where a lot of BDD has come from, although it's changed over time. Well,
we're there.
All right, thank you, Kobe.
Okay.